Hi, in this video we are going to discover factorial notation and its relation with binomial expansions. As a definition, a factorial is a product of numbers. So if I write n factorial, then I go like 1 times 2 times 3 times 4 times up to whatever n is. So if I go like 3 factorial, I write 1 times 2 times 3, which if I calculate, I end up with 6. And if I calculate 5 factorial, then I go like 1 times 2 times 3 times 4 times 5, which means 120. And the first 4 factorials, starting from 1 to 4, does not have a 0 at the end when you calculate it. So 4 factorial is 1 times 2 times 3 times 4, right? This ends up with 24. But after that, starting with 5 factorial, every calculation regarding factorials end up with a 0. Factorials by themselves are used to calculate the number of arrangements of a given number of objects. For example, how many different ways can a red bead, a green bead, and a blue bead be chosen? So for 3 different objects, it's not that hard. So I go like red, right? And then I go blue. And then I go green. Now, this is one order, right? I'll then go like other possible orders of red, green, and blue, and you can see that it's a total of 6 different ways to order a red bead, green bead, and a blue bead. Now, without doing this, what I can do is to just say that there are 3 spots, right? And for the first spot, for this one I mean, for the first spot I have the possibilities of red, green, and blue, right? So I have 3 possibilities. Then regardless of the choice, it could be red, green, or blue, right? Regardless of the choice, I will have 2 possibilities or choices for the second spot. And for the third spot, I'll only have 1 choice, right? So suppose that in the first one, you just choose red. For the second spot, you have 2 choices. You choose blue. And for the third spot, you only have green to choose, right? So if you multiply these, because it's going to be red and blue and green, it's the probability after all. So if you multiply these, you end up with 3 factorial, which is 6, right? So factorials are used like this. Now, of course, you can discuss that, well, there are just 3 beads, so why would I, work with factorials? But if you have 5 beads, if you have 10 beads, or people to choose in an order, then this is very useful. So basically, n factorial in general tells me the number of arrangements of n objects, right? How are we going to approach this problem? How many different ways can first, second, and third place prize be awarded among 8 contestants? Now, the idea is pretty much the same actually. We have 3 slots, so this is the first prize, this is the second prize slot, and this is the third prize, and we're going to write names under these, and there are 8 choices, right, for the first prize, technically speaking, of course. And then just because one of the 8 contestants is chosen, there are 7 contestants left for the second prize, and the similar argument applies for the third prize. So there are 6 contestants remaining, and if I just multiply these, I'm going to end up with 336 different arrangements. Again, for this particular problem, it's easy to calculate, but if the numbers are bigger, if I have 15 contestants and I'm giving 6 prizes and so on, Yeah, it's gonna be, too long to do these calculations. So the question is, how can I end up with this calculation? I know how to calculate, let's say, 8 factorial, yeah? And 8 factorial means 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, right? All I want to get rid of is this bit, yeah? This is 8 times 7 times 6, which appears in 8 factorial, but there is this bit too. But look at this. This means it's 5 factorial. So for this calculation, if I end up with 8 factorial over 5 factorial, then I'll have the products, right, of which I can just simplify these and end up with this product, 8 times 7 times 6. So basically, I can just say that this could be written as n factorial, so I have 8 contestants, so 8 will go here, and I'm choosing 3 winners, so it's going to go like n minus k factorial, meaning 8 factorial for n being 8, right? And k being 3, I'll be writing here 8 minus 3 factorial, which will be 5, right? So this is called as the permutations. So if you want to calculate k number of ordered groups among n objects, then we are calculating permutations, and this is the formula. So we denote this as n permutation k. So you can see this in your calculator as well. Whereas the same calculation will not apply to this problem, which says how many different ways can Mr. B award 3 merits among 8 students. Just because the merits are equal, so it's not like first prize, second prize, third prize, the order is not important anymore. So I can pick any 3 students and then I can just give them merits and everybody will be happy. Nobody will be disappointed because they were chosen second or third, right? Because I'm giving the same award to 3 people. Now, the idea is that the order is not important, changes the calculation slightly. So yes, I am going to calculate 8 factorial divided by 8 minus 3, which is 5 factorial. But here, this is still permutation and order is still important there. Which means for 3 students A, B, C getting 3 merits, in this calculation, A, B, C, this order, and B, C, A, for example, are counted differently. But just because the awards are the same, this is no longer important. So as there are 3 slots, and there are 3 possibilities for the first one, 2 for the second one, and 1 for the third one, and this means a total of 6 different arrangements of 3 people getting 3 merits, or namely the total of 6 different arrangements is now calculated as 1, because these now mean the same thing, because all of these people, regardless of order, will get the same merit after all, right? So I have to get rid of this calculation. So there are 6 calculations here, it must be 1. So how am I going to do that? Well, this was the permutation, 8 factorial over 8 minus 3 factorial. Now, I have to divide this calculation by 6 again, which is 3 factorial, right? So that the ordered trios will not be counted anymore, right? So this calculation will give me 56 different ways to just give 3 merits among 8 people. This is called as combination, and it's shown as NCR. Now, this means R choices among N objects where the order is not important. In your calculator, you can see the permutation calculation, which we won't be using much in here, whereas the combination calculation you will see here. So pressing Shift and then the division button will give you the calculation. So basically, to calculate the combination of 3 choices out of 8 possibilities, you have to exactly write this one. So you will press on 8 and then Shift and then division and 3 and then of course equal sign, which will give you the answer. And in the meantime, you will be seeing 8C3 in your calculator screen, where C is going to be slightly bold. Now, what is it to do with binomial expansion? Well, if you consider x plus y bracket squared, which means x plus y times x plus y, well, we're going to expand these like x times x, x squared, x times y, xy, y times x. Well, we generally write this in alphabetical order, but if you follow this order, you should be writing yx, and then y times y, which is y squared. Now, what happens is, although these two are written in a different order, just because this is multiplication, they mean the same. The product is the same. So I will be counting these as the same. I'll be writing it as x squared plus 2xy plus y squared. In other words, you can see that this coefficient appears here based on the idea of combinations, right? So generally speaking, I can calculate those coefficients by using the combination formula, which means I don't need Pascal's triangle anymore. I don't need to write 1, 1, 1, 1 plus 1 is 2, and so on, right? I will just write, well, if I have x minus y to the power of 7, then I can just calculate 7 in combination with 1, 7 in combination with 5, or generally speaking, any coefficient I need with the combination calculation. There are a few ways of writing combinations. We can write the combination of R objects chosen among N objects like this, and capital CR, or we can write them as column vectors. Well, they're not column vectors, of course, but they are denoted as very similar to column vectors. So it is like N and R written here, right? You will see these two notations basically, right? And these both mean the same thing, which is n factorial divided by n minus r factorial times r factorial. Well, you don't need to know this, because in your calculator, if you press on Shift followed by the division button, you're going to get this C symbol here, which will help you calculate the combination with your calculator anyway. Now you're going to see in the next video how we calculate those coefficients in the binomial expansion. Thanks for watching.